Number 31. The following data have been determined for the reaction. And then we have I minus plus OCl minus yields IO minus plus Cl minus. And then we have a lovely chart here. And from this chart, we have to determine the rate law and the rate constant for for this reaction. Okay, so seems like, let's just dissect what's going on in this chart. Seems like we have 3 different trials, trial 1, trial 2, trial 3. So maybe what I'll say is, here's my trials, or you can call them experiments. It does not matter. But for each trial, we have a predetermined concentration molarity of my I minus and a predetermined concentration for OCl minus. And with those concentrations, out comes a rate for that reaction, how fast that reaction is going to run. And with different mix and matches of concentrations, you output a different rate of reaction. So from this information, we just have to find the generalized, well, not the generalized, but the specific rate law for this equation. And this always comes from the generalized rate law. Now, just one thing, guys, is that whenever they give you trials, like a chart like this, especially if you have 3 columns, and they're asking you for a rate law, they're secretly asking you to find something else. And that secret thing that they're trying to, make you find is the orders. So whenever they're asking for a rate law and they're giving you trials, we need to find the orders. And what are the orders? Well, this comes from that generalized rate law formula, which is this right here. Rate equals K times the concentration of the reactants raised to their orders. So in this case, we have to just find out those exponents. When you are writing a rate law, you do not give a number for the rate, you do not give a number for K. All you have to do is just find out that order because you don't even give values for your reactants. So let's just try to make it as specific as we can right now. So our specific rate law would be rate equals the rate constant. They did not tell us what the rate constant was, and after we find the rate law, we have to find the rate constant, times by the reactants. Now in this case, there are 2 different reactants, I minus and OCl minus. And here they are again, I minus and OCl minus. So I should have 2 brackets, and just know that if you have multiple reactants, those are always multiplied by each other. So in this case, we have I minus. That's I don't like that. Oh boy. Okay, Christina, just stop it. Okay, so we have I minus and times by OCl minus. But now the question is, what are those orders? That's what we're trying to find. So right now, do we know the order of I minus? No. So we usually just give a ratio, or not a ratio, we give a variable. And let's just call it an x value, right? I don't know what it is, so I'm going to call it x. Do we know what the OCl order is? No. So I got to call it a variable. But if we call it variable x, that means that when we solve, these are going to be the same order. But do we know that? No, not for certain. I mean, this could be a 2 and this could be a 1. So I can't say that they're both x because I don't know if they're the same number. So I just have to label this as a different letter. Pick any letter you want. A, B, C, D. What's that meme? A, B, C. Nicolas Cage doing the alphabet. Anyway. Yeah. But anyway, let's just keep going, shall we? So we have our specific rate law formula here. Now all we got to do is find those orders. Well, how do we do that? Well, this goes back to algebra. Now I have 2 variables. And generally, when we do solve with algebra, we only get one answer that says x equals, or one answer that says y equals. But there's nothing that we've done, this isn't calculus, right? There's nothing that we've done where we can solve for x and y in one equation. So the idea here is I got to get rid of one of them. right? If I want to solve for x, I have to somehow get rid of the y. And if I want to solve for y, I got to get rid of the x. So this is where we go into our trials. And what we're going to do is we're going to make a ratio. I almost said a relationship. That was a combination of ratio and relationship. Relationship. Gotta love it. But anyway, we have to make a ratio in which we're going to put one rate law over another rate law. And if we have the same concentrations, we can cancel one of the concentrations out. And that's how you get to the other order. Now let's see. Let's say that I want to solve for, I don't know, doesn't really matter. Let's just say that I want to solve for I minus. And we want to specifically solve for that x value, right? So in this case, if we want to solve for the I minus, we need to pick two trials in which the concentration of the OCl cancels out. Because if it cancels out on the ratio, goodbye y, you're going to be solving for x. So we're going to pick two trials in which that concentration, the OCl minus, stays the same. So I'm going to look up at my trials, and I'm going to go to the OCl. Is there any two trials in which OCl minus is the same? Yeah, trial 1 and 2. So I know that I'm going to use these two trials to get my x order. Now, to make it easy for yourself, what I would do is I would always put the higher rate value and divide it by the lower rate value. This just makes it easier when you're doing your math when we're, at the stage where we're actually going to be solving. So in this case, I'm going to look for my rates, and I see that 6.2 is larger than 3.05. So for me, I'm going to do rate law number 2 divided by rate law number 1. And what this means is you're just going to plug in the numbers for rate law 2, so all the information for 2, and divide it by all the information for 1. And then see what you get. So let's do it. Let's do rate law 2. We're going to follow this formula. The rate for number 2 is 6.20 times 10 to the negative 4th equals the rate constant, which we don't know, which is K, times the concentration of the two reactants, right? I guess we'll put I minus first. So in trial 2, I minus is 0.20. And that's going to be raised to the x, but I'll do that in a little bit. This OCl minus is the 0.05. This is raised to the x, and this is raised to the y. And this is now all divided by the rate law number 1. So I just take all this information. So now it's going to be 3.05 times 10 to the negative 4th equals K times the concentration of those reactants raised to the x and the y. So the I minus is the 0.10, and this one doesn't change. So now when we plug in those orders, this is raised to the x, this is raised to the y, what can we cancel? Well, it's okay that we don't know what the k values are, right, the rate constant, but a k divided by k, that's the same unit, so bye-bye, it gets canceled out. And then the same thing with your concentration of the OCl minus. Since the number is the same and it's linked to the y variable, this guy's go bye-bye. So now you're just down to two things. We just have to divide both rate units, and then we just have to divide those numbers in the coefficients. So let's see. I'm just going to maybe, pull this up a little bit. Pull this over just so I have a little bit of room. And now let's do the division. So 6.20 times 10 to the negative 4th divided by 3.05 times 10 to the negative 4th. And I get roughly a 2, right? At this stage of the game, if you can see that your number is going to be very, very close to a whole number, just put it down as a whole number. So this is 2 equals 0.2 divided by 0.1 is 2, but if you want to, see it done, there it is. and this is raised to the x. So you say to yourself, 2 to the what will get me 2? Yeah, you got it. X in this case is going to equal 1. So we just found out the order for the I minus. So we know now that this x value is going to be a 1. Okay, so maybe what I'll do is I will erase this and just put a 1 here. Now we have to do the same thing for the other trial. So what I'm going to do is I'm just going to swap these guys, right? So if we want to solve for the OCl, we need to pick 2 trials in which the I minus stays the same. So maybe what I'll do is I'll just erase these and we'll treat it brand new. And let's see. I'm going to use my same rationale. If I want to solve for the y, the order for OCl minus, I need to pick 2 trials in which I minus stays the same. But, oh no, they didn't give us that. Well, in this case, guys, I can't do the equation. So, thanks for joining. I hope this helped. I'm just kidding. In this case, when they do not give you 2 trials that are the same, you might see that. So if they're, if the question is being kind, they will give you 2 that are the same for one reactant and maybe, 2 that are the same in another reactant. But if they throw you a curveball like this, that's okay, because we just found out the X value. So instead of canceling it out, we're just going to do the math. A little bit more complicated, but the math is there, so we can do it. In this case, it doesn't really matter what 2 trials you pick. Just abide by the rule that, higher over lower. It's just going to make it easier for the math in the end. Meaning, look how easy this math was. 2 and 2. So that's what I mean by that. So let's see. I'm going to look and I'm going to say, I can't do this one because then the OCl minuses would cancel out. So I either do a 3 with a 1 or I do a 2 with the 1. No, just kidding. I need to do a 3 with the 1 or a 3 with the 2. Because in those instances, you have a change in the OCl minus. And that's what we want to solve for. So I guess maybe we'll do 2 and 3. What you can do is, if you want, you could do 3 and 1 and see if we get the same exponent. Higher rate over lower rate. 6.2 is higher than 1.83, so I'm going to do rate law 2 divided by rate law 3. Okay, so essentially, literally the same thing that we wrote for this one is going to be the same as rate law 2. So rate law 2 was 6.20 times 10 to the negative 4th equals the K value times the concentration of those 2 reactants. So what do we got? We got 0.20 and we have 0.050. And now we know that the 0.20, that's the I minus, that's going to be raised to the first. And this is going to be the Y value. Now divide that all by rate law 3. So this piece of information, 1.83 times 10 to the negative 4th equals the K value times by the concentration of those 2 reactants. So let's see. For rate law 3, I minus is 0.30 and the other one is 0.01. Yep, 0. And this one's raised to the first and this one is raised to the Y. Cancel stuff out that you can. So K's cancel out again. And in this case, that's the only thing that you can cancel. So now we just have to do 3 divisions. We have to do the rate division like we did before. We have to do this division. And then we have to do the Y division. So let's go from left to right. 6.20 times 10 to the negative 4th divided by 1.83 times 10 to the negative 4th. And you get 3 3.38 or 3.39. Now this number is not close to 3, right? The other one, you see how the other one was like 2.0? That's a 2. This is 3.38 something. I can't just say, hey, that's a 3. So I'm just going to put down that fraction, or not the fraction, the decimal. I'm going to say, okay, 3.39, I guess, equals, now let's do this. Now, each one of these is raised to the first. So remember, anything raised to the first is itself. So I'm just going to be doing the 0.2 divided by 0.3. And I get, I always do that. That's okay, though. I get 0.667, and that's being times by the 0.05 divided by the 0.01. And that's going to be 5. 0.05 divided by 0.01 is a clean 5. And that's going to be raised to the y value. So maybe what we'll do for right now is, let's see. What I'm going to do is, I'm just going to get rid of this. So pause the video if you need to. I'm just going to get rid of the first one that we did because we don't need it. But what I'm going to do is I'm just going to move this over and pull this up. So now I can work, down here. So now, just use your PEMDAS, right? I want to get the 5y to itself, so I'm going to divide on both sides by the 0.667. Okay, so this goes bye-bye. And now this is going to be a clean y to the 5th, or no, just kidding, 5 to the y. And then I'm going to take that number up there, I'm going to try not to round, the whole number that we found out before, divided by that 0.667. And now you see, that's a 5.0. I can cut it off and say, hey, that's a 5. So now, 5 to the what will get me 5? Yeah, y equals 1. All right, so we just found the second order. Yay! This y is going to be raised to the first. So I could just erase this and put a 1. So pause the video if you need to. I'm going to now erase all of this because I need to use the space to get to the next question. So bye-bye forever. That's okay. It was good work, but now it must go. All right, so we can say that this is our rate law, or if you want to be a little bit more specific, remember that anything that's raised to the first is the same thing. So I can get rid of this one, and I can get rid of this one. Pull this a little tighter, and that is the answer. So the first part is, I do not like that. That's nice. Is it just me? I think it's just me. But you guys know me by now. Anyway, here is our lovely rate law. Now, from this information, we can solve for the rate constant. And remember, the rate constant is, or maybe I'll just say, it's the k value. So in this case, this is more like teacher or professor specific, in which some teachers may want you to get the rate constant for each trial, and then just take the average of all the k's that you found. Some teachers or professors says it doesn't matter what trial you take. Some teachers or professors, have a habit of taking the last one. I'm going to take one trial, and if you want, you could take another trial and see if the k values are going to be the same. Hint, they should be very similar because it's a constant for all the trials. So maybe what I'll say is, okay, I'm going to pick trial 3. So if you want, pick, trial 2, trial 1, plug in the values and see what you get. All I'm going to do is I'm going to use the rate law that I just found and the trial 3 values. So let's see. The rate is 1.83 times 10 to the negative 4th equals the k value times by the I minus and the OCl. So the I minus is 0.30 and the OCl is 0.010. So let's just clean it up and solve. 1.83 times 10 to the negative fourth equals 0.3 times 0.01. So no, I just gave 0.01. Yeah, you should get 2 zeros afterwards, so that looks good to me. 0.003, and that's times by k. And then, just solve for k, divide on both sides by the 0.003. And cross that out. And now I'm going to take the 1.83 times 10 to the negative fourth and divide it by this value. And there you go. 2 sig figs. Love it. So we're going to say k equals 0.061. Now, the hardest part for this, especially if you're trying to find the rate constant, is what is the units of k? Now, the units of k can be tricky because the units of k is directly linked with the overall order of the reaction. So even though they didn't ask for the overall order, what you should do is find the overall order. But this is pretty easy because overall, total, kind of means a sum. What you're going to do is you're just going to take all the orders that you got and add them up. Remember when we did our rate law that the I minus had an order of 1 and the OCl minus had an order of 1. So I had a 1 and a 1. All we have to do is sum them up. So 1 plus 1 is 3. Just kidding. Just kidding. It's 2, if you haven't noticed. But anyway, so we have an overall order of 2. And the thing is that I think it's easier to just memorize your units of k that go with that specific overall order instead of trying to plug in units into your specific rate law and solve for the k. I don't like that. I like to just memorize. It's easier. So if you have an overall unit of 2, which is the second order, that means that your units of k are going to be generalized by saying that it's a molarity to a minus 1. I say molarity because 9 times out of 10 you will be using molarity values and not ATMs, but just double check on that. But the minus 1 is always going to be the same. And then it's time to the negative 1. So always look at your rate values to see what time is given. Could be seconds, could be minutes, could be hours. And in this case, in the rate, they gave me a second. So the units of k, since we have an overall order of 2, is molarity to the minus 1 and then seconds to the minus 1. Or you could just put s, but that's it for this one. There you go. Okay. Voila. Wunderbar. That's it, guys. What'd you think? I hope this helped you out. Let me know in the comments. Thank you for sticking with me for 27 hours, 37 minutes, and 41 seconds. Because that's how long it feels. But at this stage of the game, I question my sanity, but I do not question my appreciation for you guys. I do this all for you guys. Seeing all the comments coming in, telling us, how much this channel has helped you out. It really, puts a smile on my brother and my face. Yeah, my face. And yeah, thank you so much for coming to this channel, for getting your educational needs. We have physics and math videos on the channel as well. We got almost, thousands of videos for you guys out there to help you out in your classes. And in the future, hopefully we could spread out to different subjects because we can do more. So we're almost done with chem. And I think we're moving on to different things. So check in the links in the description. We got goodies for you guys coming up in the future. And always check back because we update as much as we can. Once again, thank you. You guys are greatly appreciated. And I hope you're having a great day out there. All right? So wherever you are in the world, I hope you have a great day and a good night's sleep. And I'll talk to you soon. Okay? All right, bye-bye.